So Jessica correctly said that B was 1. And then she said if you go down 1 and over 2, that means the rise is -1 and the run is 2. So that's a -1 over 2. So she said the slope was -1/2. And therefore, she came to the equation that y equals -1/2 x plus 1. Now, you know, Matt made a mistake there early on. He had the right idea, but he actually ended up putting, if we go back to this illustration here, he put the 1 and the 2 together and made it a point, rather than thinking of this as 0, 1 and the point 2, 0. As a matter of fact, after we taped that, I pointed that out to him, and then he was able to figure out the equation of a line just fine. Okay, now suppose I were to take this ordered pair, 0, 2, or rather 2, 0. Imagine there's a 0 over there. And now this is no longer the y-intercept, so let's try getting the equation of this same line if I use the point-slope equation of a line. So what I'm going to do is take the point 2, 0, and I'm going to take the slope -1/2, and I'm going to substitute that into the point-slope equation of a line, and I get y minus, what number is going to go here? 0. Equals -1/2 times x minus 2. Yeah. So, you see, in this case, this is really a more all-purpose formula, because in the first equation, you have to have the y-intercept. Here, you can have any point at all on the line. So we have y equals -1/2 x plus 1 when I multiply that out, and sure enough, it is the same equation. Now, as far as I'm concerned, you could say this is the equation of the line. In fact, you could take out the 0, perhaps. That would help a little bit. Or you could multiply it out, and then in this case, you have the slope-intercept equation. The slope-intercept equation. Now, if I want to get the standard equation of the line, what I'll do is get everything over on one side. So I'm going to move the -1/2 x over and move the plus 1 over. So I'm going to add a 1/2 x. I'm going to subtract a 1. And I get a 1/2 x plus y minus 1 equals 0. And you see now this is in the standard equation form. What's one thing I might do to that to make it look a little nicer? What would you say, Stephen?
Get the 1/2 off of the x and make them all whole numbers.
Exactly. So what would you do to get rid of the 1/2?
Times the entire equation by 2.
Right. So I'm going to multiply both sides by 2, and this becomes x plus 2y minus 2. And then I'll multiply on the right by 2, but it's still 0. So most people would say this is the standard form answer where you have integer coefficients in that case. Okay, let me just ask you now one question that is related to this. So we'll just make up a problem right here on the spot. And what if I tell you that I have a line? I'm going to draw a line on here on this graph paper. And I'm wondering, what is the equation of not this line, but a line that passes through this point right up here that's perpendicular to it? Now let me just draw this in freehand so I don't give away exactly what the slope is. But somewhere along here, there's a line through 3 on the y-axis. I think if we put that under white paper, it'll show better. And I'm wondering, what's the equation of this line, knowing the line that I've drawn right here? So this one's given, this one I'd like to know. So the first thing I'll do is figure out what's the slope of the given line. Can anyone tell me what's the slope of this line that I've drawn? Yeah, Jeff.
-3/2.
Let's see. Well, now it looks like starting from here we went up 2 and over 3. Oh, yeah. So you were thinking of the perpendicular. Yeah. What's the slope of the original line?
2/3.
2/3, yes. So this line has slope 2 over 3. So therefore, Jeff, what's the slope of the perpendicular line? -3/2. This line has slope -3 over 2. Because the rule is that any line perpendicular to a given line, the slope is the negative reciprocal of the original slope. So this is the negative reciprocal of 2/3. So the last thing then is, what's the equation of this line? Can anyone tell us? Well, what's the y-intercept?
3.
Yeah, it looks like it's 3. And we know the slope. So we're going to use the equation in this case, y equals mx plus b, and the equation is y equals negative 3/2 x plus 3. That's the equation of the mystery line. Now, you notice I never did have to find the exact equation of the given line. What I needed was the slope of it, and that's all we needed in that case. Okay, let's go on to another topic. I'd like to remind you about interval notation, which you use more and more in future courses, but you've probably only seen a little bit so far. If I draw a number line along here, and let's say this is 0, this is 1, this is 2, maybe this is -1, here's -2. Then what if we take the interval of numbers including -1 over to 2? I'm going to put a solid dot there, meaning I'm including the endpoints. There's a shorthand abbreviation for that interval. Jesse, do you know how you write that?
Yeah, you use a bracket.
Mm-hmm.
-1,
Yeah.
comma, 2, bracket.
Square bracket. And this square bracket means that you include the endpoint. Now, what if I change the problem and I made this an open dot here and an open dot here? In that case, somebody else who can tell us how you would represent that? David?
You would just change the brackets to parentheses.
To parentheses, yeah. So now this becomes parentheses -1, 2. Of course, a person might say, you know, Dennis, that looks like you're plotting the point -1, 2. Doesn't it look like the ordered pair? So how are we supposed to know if you're talking about an interval or plotting a point? Well, what you do is take it in context. If we're talking about a portion of the number line, then we know this is an interval. And if we talk about, if we're plotting a point, then obviously this is an ordered pair. One more possibility, what if we start at -1, say including -1, and we want to just keep on going? We just keep on going all the way out. How would I represent that using this sort of abbreviation? Stephen?
A square bracket,
Uh-huh.
-1,
-1.
comma, infinity.
Infinity, yeah. So it's going to go all the way out to infinity. And by the way, when I put infinity there, do I put a parenthesis or a square bracket? Yeah, what's the reason for a parenthesis as opposed to a square bracket?
It'll never touch infinity, so...
Yeah, because there is no last point. See, if you put a square bracket, it means you enclose the last point, and there is no last point if you're going to infinity. So the standard procedure is you always put a parenthesis on here. And if I were going to, say, begin at 0, but not including 0, and take the numbers all the way down without end, how would I abbreviate that? Susan, how would I write that?
Parentheses, -infinity, comma 0,
Comma 0.
parenthesis.
And parenthesis, exactly. This first interval up here with the corner brackets, that's referred to as a closed interval because we sort of closed the door, we included the last number. When I use parentheses and I don't include the last numbers, that's called an open interval. In this case, this is a closed interval because I did include the last number on this end and there wasn't a last number. So this one is a closed interval and this last one is an open interval. Now, one more possibility, what if I take these out? Let's go back to this first case where I had -1 to 2. And suppose I started at -1, including -1, and I went up to 2, but I didn't want to include 2. If I use this notation, what's one thing I'll have to change there?
The bracket by the 2 would have to be a parenthesis.
Exactly. I'll just put a parenthesis here. So in this case, we would call that a half open or a half closed interval. Like, you know, is the glass half full or half empty? It's up to you. It's a half closed or half open interval. Okay, let's try working a problem that asks us to use this,